Hello everybody, my name is Shelby Harris and today I'll be talking to you about the process of glycolysis. And all glycolysis is that it's the first step of cellular respiration. And after glycolysis happens, the Krebs cycle or the citric acid cycle, and then after that it leads on to the electron transport chain. But all glycolysis is that it's the process in which glucose is broken down into two pyruvate molecules, and that it has a net yield of 2 ATPs at the end because it produces 4, but it uses 2. And so in the first three steps are called the investment steps because they are ATP requiring steps. They start off with a glucose molecule and then they use 2 ATPs and they end up with 2 molecules of glyceride 3-phosphate or PGAL. Look at step 1. Step 1, a phosphate group is transferred from the ATP to the glucose molecule. ATP turns into ADP because it loses a phosphate and makes glucose 6-phosphate. So you look at the picture, you have your glucose molecule, you have your phosphate coming from the triphosphate because it has 3, coming down here to the glucose 6-phosphate. And then you have your diphosphate leaving over here because it only has 2. You come to step 2 then, and in step 2, one more phosphate is transferred to the glucose 6-phosphate by another ATP molecule, and it makes fructose 1,6-bisphosphate. So like before, you have another phosphate coming onto your glucose 6-phosphate, making the fructose 1,6-bisphosphate, leaving you with the ATP. And then step 3, your fructose 1-bisphosphate is unstable, so it splits into 2 different molecules. It splits into a molecule of dihydroxyacetone and a molecule of glyceride 3-phosphate, or PGAL, and your deoxyribonucleic turns into PGAL too also. So you have 2 molecules of PGAL coming in. See, so you have your 6,1-bisphosphate, your 2 PGALs. And in the final 3 steps, these are called the payoff steps because they are ATP producing steps. You begin with the 2 PGALs molecules that you ended up with in the first 3. And you end with 2 pyruvate molecules at the end. So you come to step 4, and both of your PGALs receive a phosphate group from 2 NAD plus molecules. And each NAD plus molecule receives 2 electrons and a hydrogen ion from your PGAL. And those 2 NAD plus molecules become 2 NADH molecules because you gave them the hydrogen. And then your PGAL becomes phosphoglycerate, or PGA. So you have your 2 PGALs and your 2 ADD pluses, and then you get an extra 2 phosphate groups on here to each one. But you also lose your 2 electrons and your hydrogen ion to make the NADH. And NADH is important because they use that later on in the electron transfer chain, which is the final step of cellular respiration. So that's really good that we make it there. And then you come on to step 5, and then step 5, the PGAs use 2 ADPs to create 2 ATPs, this is your first time that you create ATP by yourself. And then your 2 PGAs turn into 2 phosphoenolglyceric acids, or PEP molecules. So here we go, we have your 2 PGAs, your 2 ATPs turning into ATPs because they lose the phosphate right here. And then you only have your 1 phosphate on your 2 PEP molecules. And then the final step, step 6, the remaining phosphate group from PEP is attached to the ATPs to make ATP. And the 2 pyruvate molecules are formed from this. And that gives us the net incomes of our 2 ATPs. You just paid off the loan from step 5 of your 2 ATPs. So you look at the picture. Here's your 2 PEPs. And each one gives a phosphate group to the ADPs, making your 2 final ATPs. And then you end your process with your two pyruvates. And the two pyruvates then go on to either go on to the Krebs cycle or the citric acid cycle, or they either go on to fermentation if there's no oxygen. Fermentation requires no oxygen, while the Krebs cycle does. And that's why we have glycolysis, in order to create those first two ATPs and the pyruvate that will lead us into the next steps of cellular respiration. So thank you. I hope you enjoyed my video. I hope it helped you to figure out how to work glycolysis, because I was really confused on it the first time I saw it. So thank you.